Hello everyone. In today's session, I'll try to cover very few questions, selected questions in the minimum time frame that are more relevant with the NEET firstly. Second, which are given in the NEET mock test in the Abyas app. New reactions maybe which are not frequently covered as per NCERT or as per the NEET syllabus. So this part, these type of questions I am going to cover. This is from mock test 1 to mock test 5, but I am not going to tell it is exactly from which mock test, because if you are going to solve it, then you listen it carefully. Maybe this type of question is there, so you can recall what I have explained first. If you have already solved that module or solved that paper, then you should answer it correctly, right? So starting with the first one. In the first, it is IUPAC name. You have to simply mark the correct numbering. I have given you 5 questions, you try on your own and then I will explain it. Second, again give the correct numbering, because if you give the correct numbering by seeing the option, you can easily eliminate. Third question is about acidic strength order, or which will protonate fast, decreasing order we have to decide. Fourth question is about reactivity order towards diazo coupling reaction with phenol in alkaline medium. This reaction I have covered in amines video. At the end it is almost, or in the named reactions one video, it is all reactions are mentioned with their time in their particular video. There also diazo coupling is mentioned in named reactions. Okay, so it is reactivity order of these diazonium salts when they are reacted with phenol. Then fifth is about E2, major E2 product formed with this substrate. Okay, this part I have given in stereochemical one video, which is are they enantiomers, diastereomers or identical. In that video I have covered that how to write wedge dash to Fischer, and E2 reaction I have covered in alkenes topic. Okay, so write down the answers. I am explaining them one by one. Starting with the first one. In the first one we have two groups. One is question number 1. In this part, there are two functional groups, which is senior amide group, and it is carbon containing. Numbering will start from C of the amide. From there, numbering is starting 1, 2, 3, 4, 5. Now it depends on the options, right? If you have gone through that example given, only one option will be given. Either aldehyde carbon is included or aldehyde carbon is not included. Generally, we do not include aldehyde carbon, that means we use the term formyl. Another possibility is if aldehyde carbon is included, then the term oxo is used. This type of example already covered in the IUPAC nomenclature, where we have covered aldehydes. There both example I have, in one example both type of nomenclature I have told you. Maybe in the IUPAC part 2 it is covered in functional groups. So here 1, 2, 3, 4, 5. Now with fifth carbon CHO group, which is becoming a prefix. So it is formyl when it is a prefix. And if we consider its carbon, then it becomes oxo. So one possibility is 5 formyl, okay, and 2 methyl. 5 formyl, 2 methyl, and you can go through the options, you will get that one. Other possibility is if you consider its carbon, it becomes 6th carbon and we say it is oxo. Then it becomes 2 methyl 6 oxo, and then root word is hex at third position in, and then amide. So here the main part is giving correct numbering and considering which option is given either with formyl or oxo, because both are correct, so they have to give only one option, that is first one. In second one we have a no functional group, only multiple bond, that means select longest chain and give minimum number to multiple bonds. So if you try with that one, 1, 2, 3 from this side, suppose you are getting third number for multiple bond. Here I am not talking about double bond or triple bond, I am saying multiple bond. 1, 2, 3. Right side 1, 2, 3. Both sides you are getting same number for multiple bond, 3 from right side, 3 from left side. Then we check where we are getting any other difference, like where we are getting substituents getting less number. From right side we are getting second number for methyl. from left side we are getting on third number ethyl. Now after multiple bond number with same number for the multiple bond, 3 from both sides, we try to find any other difference which is present here in the form of second position is with substituent. From the left side, third position is with substituent. Now which side is preferred? Right side we have to start numbering, where we are getting minimum number for multiple bond as well as less number for substituent. If there is an exact tie-up, like both sides we are getting same number for substituent also, then double bond is preferred over triple bond. But it is only when every thing is tied up, like their numbering is also there, substituent numbering is also there, no difference, then double bond is preferred. Otherwise, always try to find any other difference in numbering is given or in the position of substituents are given. So from the right side we do the numbering 1, 2, 3, 4 and so on. Now you can easily identify from the options that what is the correct naming of the correct name of this compound. Okay, like here second position methyl, sixth position ethyl, to be firstly mentioned alphabetically, sixth ethyl, 2 methyl, then root word oct, then 5 in 3 ine. So ultimately we'll easily find it out. The main point in this question was do the correct numbering. Next question is about acidic strength. That's why here written Ka, or we can say which is fast protonation order. Among them, we know that in the acidic strength topic, in the GOC I have told you some basic points. As we go down the group, the acidic strength increases. So OH and SH, which is more acidic, we say clearly SH is more acidic, and more are the electron withdrawing groups present, more will be the acidic strength. So on that basis we will compare and go through the options given. So here SH, SH. Now in this case there are 2 withdrawing groups, here 1 withdrawing group. Inductive effect is there. Where more inductive effect? At second. Then SH still there, it will lose H plus. Here 1 Cl is present, again minus I effect. So second, then first. Now among these two alcohol, where we are getting withdrawing effect, it is Cl present here, minus I effect, third, and last will be fourth, where there is no withdrawing effect and it is OH group. So OH is less acidic than SH, we have used this point. And second point we have used to compare among SH groups, that where there is more withdrawing group, it will be more acidic. So this is from which concept? In GOC, it is covered in the part of acidic strength. Then fourth question is about the diazo coupling reaction. Now in diazo coupling, you have gone through already in the notes also, you have seen in the video part also it is covered that in diazo coupling, diazonium salt acts as electrophile, right? And it attacks on the electron rich rings, the rings which contains highly activating groups like OH, OR, NH2, NR2, like this. So here already mentioned phenol, and this is important reaction also, phenol in slightly alkaline medium is taken. So here what we have to decide, reactivity order of the diazonium salts towards diazo coupling reaction, which is simply electrophilic aromatic substitution. Okay? Now in this case, in this part all are electrophiles. Now more are the electron withdrawing group present on the electrophile, more positive charge will be there, and more positive charge means faster will be the attack on the benzene ring or phenol ring. So more are the electron withdrawing groups on electrophile, faster will be the rate of reaction. And if electron rich rings are given, activated rings are given, then more are the electron releasing groups present on the ring, faster will be the rate of reaction. That part already I have explained through examples in diazo coupling reaction in amines. Okay? So now using that point from that video, that more are the withdrawing groups present on the diazonium salt, faster will be the rate of reaction. So among them the most withdrawing group present is in second one, which is minus I minus M. Then all are activating. Which is least activating then? CH3, second maximum, fastest among them. Then fourth, because it is least activating among first, third and fourth. Then between first and third, which is less activating? OCH3. It is from which point we are using? we are using plus M effect, we are using hyperconjugation effect, again electronic effects. And the most activating among them NMe2, that is Nr2 group. So it is most electron releasing group, so electrophile will be least reactive towards diazo coupling reaction. ठीक है, तो here which point we use rate of reaction increases as electron withdrawing group increases on diazonium salt. Then next reaction is from it is from dehydrohalogenation and using the point of stereo, which is given here, that structure. So I told you in the video that the video name was are they enantiomers, diastereomers or identical. The main motive for that was that we should write how to convert the Fisher into wedge dash or wedge dash into Fisher or Fisher into Newman projection. So here I'm using that point that if you find RS configuration for each chiral center, it is one such way. You can try another way also, but this is very accurate way because already configuration is fixed. So when you give the numbering, first numbering will be for that group. This group will comes first, ethyl becomes second, methyl becomes third, and it becomes fourth. When you find RS, left carbon will be S, right carbon will be R. Now if I want to write it in Fisher, I will consider one point that on the vertical line maximum number of carbon atoms. First carbon, on second carbon Br, third carbon, fourth carbon in ethyl and fifth carbon ethyl. So CH3 carbon ethyl, longest chain selected. Now on the second carbon Br group is there, third carbon methyl and hydrogen. So arrange them in such a way that this carbon becomes R configuration and there also arrange the group in such a way it becomes S. So here if you write it is first group, first priority, this complete becomes second, CH3 becomes third and this becomes fourth. Now rotation is 1, 2, 3 anti-clockwise, but lowest priority group is on the horizontal, so write the opposite answer. Anti-clockwise opposite is R, it is matching with that one. Similarly, if you find it for that one, this complete group becomes 1. Which one? That group. Why? Because after carbon Br and after carbon there is carbon or hydrogen. Then ethyl, then methyl and 4. Now as per numbering 1, 2, 3, it is becoming R configuration, but lowest priority group is on horizontal, so R becomes S. That means it is correct representation. Now using the point from dehydrohalogenation, E2 reaction we have done that it is anti-elimination. So Br will leave and H will leave and double bond will be there. Which groups are in front of each other? CH3 in front of ET. So you can write it like this, CH3 in front of ethyl. Are you getting it? CH3 in front of ethyl. CH3 in front of ethyl and H, ultimately if they both are in front, H and methyl will be in front. Clear hai ye? Maybe that color is little bit less visible, so I am writing it like this. Now tell me, on the double bond both CH3 are on the opposite side, that means which form it is? Trans form. Now you go through the options and you will get the answer, right? So that are the few questions right now. Now next is optical resolution, which is information, that's why I have not written the question. Optical resolution is covered in which topic? It is covered in optical isomerism, where I talked about the enantiomers or racemic mixture. Yeah, racemic mixture is a equimolar mixture of the enantiomers, and enantiomers have same physical properties, same chemical properties, but their behavior towards optically pure or optically active reagent is different. So we use chemical method of separation. This point I am telling you again that covered in optical isomerism video, you can see that part, in that it is covered. Here I am explaining very briefly that by optical resolution method we can separate enantiomeric mixture which is racemic mixture, and if we take optically pure reagent, then we get diastereomeric mixture, and diastereomers have different physical properties. So by fractional distillation we can separate enantiomeric mixture. Then if the optically active reagent is not there, or if we take optically impure, that is optically inactive reagent, better is optically inactive reagent, and then treat with racemic mixture, then again we get enantiomeric mixture, and we cannot separate that mixture into two. So we cannot use optically inactive reagent, we should use optically active reagent. So in short, that information again is repeated in one of the questions in the mock test, which is answered through optical resolution method, which is used to separate racemic mixture or enantiomeric mixture, chemical method of separation. Then next question about is three molecules are given. Question is about their dipole moment comparison. They are among them which is most reactive, and comparison of stability. Stability comparison between first and second. First and second. Now here this type of question maybe you have solved in the study material. Now in this case, if you try to delocalize the pi electron, maybe any side, suppose in the downward direction, there will be minus, there will be plus. The below ring getting plus charge becomes anti-aromatic. So anti-aromatic is unstable, although above ring also becomes, if it is below here, it becomes minus, and it becomes aromatic, above becomes here plus, it is anti-aromatic. So one ring is becoming anti-aromatic. So we should check other options. Here doing the same part, delocalizing so that any good stabilizing factor arises. There also 6 pi electrons aromatic, above 2 pi electrons it is also aromatic. So this becomes highly stable. So it is better to be like here minus and there plus, stable, more polarity developed here. In this case we do the same downwards. Why? Because if it is downwards, charges will be there, above plus aromatic, below minus. This part of aromaticity we have covered in the aromatic hydrocarbons. Some 15 examples are there which are aromatic, which are non-aromatic, which are anti-aromatic. So that type structures are covered, plus minus. Now here anti-aromatic, least possibility of developing charges because it is becoming highly unstable. This is highly stable, both aromatic. It is also stable, above is aromatic, below is non-aromatic, right? So among them the maximum dipole will be for second maximum, because most development of charge will be there due to both rings aromatic. Then third, least for first one, right? Then second is among them which is most reactive. First one will be most reactive. Why? Because it is highly unstable. So it will quickly undergo the reaction to reduce its stability. Then stability comparison between second and first. First and second simple, second is more stable than first. So this type of question you can solve more, maybe in the study material or any books you are solving, you can get this type of example. The concept is simply from the aromaticity. Delocalize pi electron and check which is getting aromatic, highly stable. Using that stability we can also infer the dipole moment. Okay. Then next is reaction which is alkane nitrile, OH minus H2O, incomplete hydrolysis is done. Now if we do incomplete hydrolysis of cyanide, it will result into amide. That means A is what? A is amide, CH3 CH2 C double bond O NH2. So this is a reaction in amines chapter covered, cyanide to amide, and it can also undergo further, but here already mentioned in the reaction incomplete, that means it is partial hydrolysis, right? Other possibilities I have written here extra, which is if concentrated HCl is given, it is also partial hydrolysis of amide. If it is given OH minus H2 incomplete, no doubt it is easy for you. But remember, if conc HCl is given, it is also partial hydrolysis, or if alkaline H2O2 is given, it is also partial hydrolysis. So you can mark such reagents. If it is not written in your notes, you can add that part, which is partial hydrolysis reagents for cyanide to amide. And then next is Hoffmann bromide reaction. If you remember, this reaction with mechanism we have covered in amines. In short, I am mentioning remove CO and combine carbon with NH2. So we will get, the product will be CH3, CH2 and NH2. That is the product formed. right? So first is partial hydrolysis, second is Hoffmann bromide degradation, both covered in amines topic. Then one more piece of information which is important because new points are there. First information is melting point of alkane increases with increasing number of carbon atoms. That you all know that as the number of carbon atom increases, more force of attraction will be there, and melting point, boiling point increases. So this is part no doubt correct. And with increase in branching. Now this part is given correct in NTA with increase in branching, although there are some deviations in the example. Most common or most important example is neopentane. If we compare N-pentane, then isopentane and then neopentane, in that case neopentane due to highly branched structure becomes more spherical, better packing in the lattice, and which we know by the experimental value. So that point is given correct in NT, so I am mentioning it also that first is correct information that with increase in number of carbon atoms melting point increases, with highly branched structures also packing efficiency increases and melting point increases. Some deviations are there, so this is the piece of information for all of us. Then next point is boiling point of alkene, which you already know by NCERT also. As the number of carbon atom increases, boiling point increases, and as the branching increases, surface area decreases, then force of attraction will be less and boiling point decreases, but decreases with branching. So that point second is normal from NCERT. Third point is totally different, which is cycloalkanes have higher boiling point. This information, if you know, very good. If you do not know, then you can, in this time you can add such points, or you can keep such points as screenshots that you keep on revising on regular basis. This point is cycloalkanes have higher boiling point than normal alkanes having same number of carbon atoms. Now the reasons given are, the reason is that cycloalkanes have more compact structures and they pack very good as compared to N-alkane. So this is one of the reasons. That is why their melting point is also high. Their melting point is already melting point is high, boiling point is high, and their density is also high. This is one such reason given. Other reason given that due to higher London force of attraction. In short, the important point is this information that cycloalkanes have higher melting point, boiling point, and they have more density as compared to N-alkanes, normal alkanes. Maybe the reason, two reasons possible. One is given in the form of more London force of attraction due to their ring shaped structure, or other is due to their more compact shape, they are better packing into the lattice. So these are the two possible reasons mentioned. Then next information again important, that among these alkyne, alkene, alkane, alkyne, alkene and alkanes, alkyne derivatives have higher boiling points as compared to alkene and alkanes, because they have more number of pi electrons, and that gives rise to more electric field, more distortion of the electron cloud, and due to that more force of attraction among the particles. So important is alkyne derivatives boiling point is more as compared to alkene and alkane derivatives. Now next is information about a reaction. Although this is, I think you all remember, ether can be prepared. It is ether from alkyl halide in presence of dry Ag2O, silver oxide. It converts Rx to ROR. For example, C2H5I with silver oxide heating, it converts into C2H5O C2H5, that is diethyl ether. If we take mixture of alkyl halide, we get mixture of ether as the product. So that is already you have done. I have written here just to remind you. Then next reaction is information, pure information, not given in NCERT, not generally used, which is formic acid with concentrated H2SO4, dehydrating agent, H2O release plus carbon monoxide. So here I am writing both reactions. One with concentrated H2SO4, that is forming CO plus H2O. If it is heated at around 160 degrees Celsius, it gives CO2 plus H2. So this is a reaction purely information based, less important as compared to NCERT reactions. But when you are solving the questions of NTA mock test, you can add such reactions. You can make that, you can write on the notebook, take the screenshot, or in the NTA paper you can take those reactions screenshots, keep a folder in your mobile, and on regular basis revise those reactions, because you cannot do all new reactions. But if some new reactions are given in mock test, you can add those reactions, keep on adding them, and as per the time you revise these reactions after third day or after fourth day. Few days interval you should revise them, because whole year most of the reactions like this you have not covered. Then another information is glycerol reaction with oxalic acid. Glycerol with oxalic acid under two temperature conditions. One given is around 100 degree. It is 110 degree, but in that test it is given 100 degrees Celsius or 373 Kelvin. So it gives formic acid as the product. How it is forming? Initially water eliminated and ester is formed. Then further given that CO2 also evolved. After hydrolysis it is formed. So again, not going much into the depth of the reaction, because it is under particular temperature condition. At around 100 it gives formic acid, again generating glycerol. At 260 degrees Celsius, twice CO2 release, twice H2O release, and finally it gives allyl alcohol. So there are numerous reactions for glycerol also, oxidation reactions, but it is not given and less important. So add this reaction which is given in the mock test. And only part is, if you are comfortable with all NCERT reactions, then you can revise those reactions. It's up to your preparation, that at which level you have prepared. So it depends to add these reactions after the NCERT reactions. The next piece of information is about density comparison among alkyl halides. Like this is Ri, because generally what happens, R group same, more is the molecular weight, more will be the density. Ri, RBr. Now H2O is after RBr, but it is more denser as compared to RCl and RF, right? Here the important comparison is among them: tetrachloro, trichloro, dichloromethane, water, and it is methyl chloride. Now among them, in this case, after dichloromethane is water. That means dichloromethane is more denser as compared to water. Therefore, this point you can use in the question which is given in the test, that CH2Cl2 DCM, dichloromethane and water are used in differential extraction. This method I have covered briefly in purification topic. In purification, quick points, quick revision is done for these methods. Their differential extraction or solvent extraction method is covered, in which organic compound, or the principle is difference in solubility of the organic compound in water and in organic solvent. Okay, more details are given in purification video. If you want to see that one, you can go through it. Otherwise in NCERT also it is given. Now here the point is, dichloromethane and water are used in differential extraction. So in the separating funnel, like this is a rough diagram I have made, which layer will be in the upper part, which component will be in the upper layer, and which component will be in the lower layer. So we know that the density of DCM, dichloromethane, is more than water, or chloroform is more than water, or tetrachloromethane is more than water. So we can use this information that CH2Cl2 more denser, it should be in the lower part. CH2Cl2 will be in the lower part, and H2O in the upper part of the separating funnel, which I have mentioned by blue color. That may be not visible due to, because it is from the camera, that mobile I am making this video. It is blue color, that is water, which is upper layer, and red color, this different layer, which is for the more denser part, that is here dichloromethane. Okay, so these are few questions from the mock test. Now you can go through the test again if you want, or you can revise those reactions which are slightly different from regular reactions we have covered in NCERT.